this video, we will discuss about find if array can be sorted. You are given a zero indexed array of positive integer nums. In one operation, you can swap any two adjacent elements if they have the same number of set bits. You are allowed to do this operation any number of times, including zero. Return true if you can sort the array, else return false. So what they are saying is that in the input, you are given an array and you need to check whether you can sort this or not by performing some operations. So what is the operation? That you can swap any two adjacent elements only if their number of set bits are equal, right? You can perform this operation any number of times, and after doing this, if you can sort this array, then you need to return true, otherwise false, right? So in this case, if you see for this 4 and 2, 4 is written as 100 in binary and 2 is written as 10, right? The number of set bits in 4 is 1 and the number of set bits in 2 is also 1. Right. So these both numbers are having same number of set bits and they are adjacent. So these two can be swapped. Right. So that is how you have to perform the operation and identify whether the array can be sorted or not. Right. So now how are we going to approach this problem? So see, 8 in binary is written as 1000. Right. So the number of set bits that it has is 1. Right. Then this 4 is written as 100. Here also the number of set bits are 1. Right. Then for this 2, it is written as 10. So here the number of set bits are also 1, right? Then this 30, so let's suppose this is having the number of set bits as x, right? And then for this 15 also, we'll suppose that it is also having the number of set bits as x, right? Now if you see here, 8 and 4, these two are having same number of set bits, which is 1, and these are adjacent, right? Then that means these two can be swapped with each other, right? So if you will swap it, what you will get? 4, 8, 2, 30, 15, right? And their set bits are 1, 1, 1, x and x, right? Now, if you see this 8 and 2, these are also having the same number of set bits and these are adjacent now. So these can also be swapped, right? So if we swap these two, then what will be the array? It will be 4, 2, 8, 30, 15, right? And here the set bits are 1, 1, 1, x, x. Right. Now again, if you see for this 4 and 2, the number of set bits are equal and these are adjacent now. So these two also can be swapped, right? So now the array will become 2, 4, 8, 30 and 15. And their set bits are 1, 1, 1, x and x. And then similarly for this also, you will see that their set bits are equal and they are adjacent. So you can swap these two also and then your entire array will become sorted, right? So now if you see here that for these three elements, they were having the same number of set bits, right? We were able to sort these three. If you see here, 8 was present as the first element. Here it is present at the second element and here it is present at the third element, right? Then if you see for this 2, here it is present as the third element. Here it is present as the second element and here it is present as the first element, right? So if you see that within these three elements where the number of set bits were equal, these numbers could be placed anywhere, right? 8 could be present here also, here also, here also. 2 could be present anywhere, 4 could be present anywhere, right? So can I say that within this part of the array where all the numbers are having their number of set bits as equal, here the numbers can be shuffled at any positions. I can shuffle these three elements anywhere within this particular part, right? Can I say that? Yes, right? So now instead of swapping, I am saying that within this particular part, I can shuffle these elements, right? And since I can shuffle all these three within this particular segment, I will always be able to sort these elements, right? Because I can place these elements in any order, right? So I can always sort them, right? So this was one particular segment or part of our array. Why? Because it was having same number of set bits, right? So these all elements can be sorted within themselves, right? But we need to check for the entire array. We need to check if we can sort the entire array, right? So now if you see that the next segment is this one, right? Now in this segment, both the elements are having same number of set bits, right? Because that is why we are calling it as a segment, right? So now these two can also be sorted within themselves, right? So this one segment can be sorted within itself. This one segment can be sorted within itself. And let's suppose if there is some other segment, then that also can be sorted within itself. The only thing that you need to check is that if we combine these three segments or all the segments, then is your entire array becoming sorted or not, right? Now, how can you identify that? How can you check that if all the segments are sorted or not? So if you see here that this is the first segment and this is the second segment, right? When these two are going to be sorted, when the maximum element in this segment is smaller than the minimum element in this segment, right? Because if let's suppose in this particular segment, the smallest element is 3, right? And you see here that the largest element is 8, right? So if you are able to sort this segment within itself and this segment within itself, and then you combine these two, then you will check that 8 will come before 3, right? And since they are not having same number of set bits, you can never swap them. This 3 can never come at this side. So then that means the maximum element of the previous segment, if it is greater than the smallest element of this particular segment, then we cannot sort these two segments, right? So in this segment here, we got the maximum element as 8, and in this segment, the smallest element is 15. Now here 8 is less than 15, so here we can say that yes, these two segments will be sorted when we sort them within themselves, right? But if let's suppose here 3 was also there and it was having x number of set bits, then in that case, in this particular segment, the maximum element would be 8, and in this particular segment, the smallest element would be 3. Now here 8 is greater than 3, so in that case, we can never sort our array, right? So what you need to check is that you can identify all the segments within your array using the count of set bits, and then you can just check for every segment that if the maximum of the previous segment is greater than the minimum element of the current segment, then you can return false there itself. You don't need to check for other segments, right? And if it is not, then you can move forward and you can check for the other segments, right? So if I remove this, so what I'm saying is that this is a segment and this is a segment, right? We need to compare the maximum of the previous segment with the minimum of the current segment, right? So now what all information are we going to need? So first we will need the number of set bits. How many set bits are there in the current segment, right? So first of all, you will consider the first element, right? So you will consider the first segment. So you can identify the count of set bits in the first element, which will be nums of 0, right? So there is a built-in function in C++ which is built-in pop count. You can use that to count the set bits, right? So in this, what you will store? You will store the count of set bits of nums of 0, that is the first element, right? Which in this case will be 1. The number of set bits in 8 is 1, right? Then what is the next information that you need? Now for every segment, you need to know what is its minimum and what is its maximum, right? Why do you need the minimum? Because when you are at this segment, you need to compare its minimum with the maximum of previous segment, right? So you should know the minimum of this particular segment, right? Then why do you need the maximum of this segment? Because when you will move to the next segment, then you need the maximum of the previous segment, right? So for every segment, you should know its minimum and maximum. So initially, we are considering only the first element. So the maximum will also be your nums of 0, right? Which in this case is 8. And your minimum will also be nums of 0, which in this case is also 8, right? And then what is the other thing that you need? Other thing that you need is the maximum of the previous segment, right? Because if this is my current segment and I am identifying its minimum and maximum and the number of set bits, I should also know the maximum number of the previous segment, right? So for that, we are using this variable previous maximum, right? Now, since we are at the first segment, we do not have any segment before it, right? So initially, we can keep its value as int min, whatever is the minimum value that we can keep inside this, so that we can consider this segment, right? Now what you can do is you can just start iterating in your array from I equals to 1 till end, right? And now inside this, what you will do? So when you are at this element, first you will check that whether this particular element is lying in the current segment or not, right? And how you will check that? You will identify how many set bits are there in this particular element and is it equals to the set bits or not, right? So you will check that if the number of set bits in nums of I is equals to the set bits, right? If it is equals to the set bits, then that means this particular element, nums of I, belongs to the current segment, right? And when it belongs to the current segment, then that means we should update our minimum and maximum, right? So what we'll do? In the mini, we will write the minimum of mini, comma, nums of I, right? And in the maximum, we will write the maximum of maxi, comma, nums of I, right? So this is the case where our current element is the part of the current segment. Now the other case is when the number of set bits are not equal. Then that means this particular element is the part of the next segment. Now we are at a new segment. Now when you are at the start of the new segment, what you should do? You should check that for this segment which is now completed, I will now have its maximum and minimum element, and I would be having the previous segment's maximum, right? If there was a segment before this, then whatever was its previous maximum, that would be stored here, right? So when you are done with this particular segment, now you should compare the minimum of this segment with the maximum of previous segment, right? So here you should check that in the else part, you should check that if the minimum of the current segment is lesser than the maximum of previous segment, then in that case you can simply return false here. You don't need to check for the other segments, right? Here itself your answer will become false, right? Otherwise if the minimum is not less than the previous maximum, then that means these two segments can be sorted together, right? So in that case what we need to do is we will update all our variables, right? So now our previous maximum, because now whatever is the current segment, that will become the previous segment, right? So the previous maximum will be updated to maxi, right? And then maxi will be updated to the current element, which will be nums of I, right? And the minimum element will also be updated to nums of I, right? And then you should also update the set bits, right? So set bits will be the number of set bits in nums of I, right? So this is what you need to do. So now you will see here that after this loop finishes, whatever will be the last segment in your array, that won't be checked, right? Because this loop will be finished, it won't come here, it won't come at this step. So after coming out of this loop also, you should check once that if the mini is less than the previous maximum, then return false, right? Otherwise return true, then we can say that the array can be sorted. So this will be our approach. So basically we are checking all the segments and we are taking the maximum and the minimum of the current segment and the maximum of the previous segment, and then we are comparing them and we are checking that whether all the segments can be sorted or not, right? So let's code it out now. So first of all, we are going to create all our variables. So first will be the count of set bits, which will be the count of set bits of the first element in nums, right? Nums of 0. So we will use the C++ built-in function, which is underscore underscore built-in underscore pop count. And in this we'll give nums of 0. So basically this function returns the count of set bits in nums of 0, right? Then we need to create a maxi variable, which will store nums of 0 initially, and mini, that will also store nums of 0 initially. And then we'll take the previous maximum, which will initially store the minimum number, right? Then we will iterate inside our vector starting from 1 till nums.size, right? And then we'll do I++. Now inside this, we need to check that if the count of set bits of the current number are equal to the set bits or not. So now again, we will do underscore underscore built-in underscore pop count. And in this, we'll give nums of I. So if this is equal to set bits, then that means this is part of the current segment only. So we will update the maximum and minimum. So maxi will be equals to max of maxi comma nums of I, and minimum will be equals to minimum of mini comma nums of I, right? Else, if the count of set bits are not the same, then we should check that if the minimum is less than the previous maximum, then that means we cannot sort the array. So we will return false, right? Otherwise, now this is a new segment. So we will update all our variables. So the previous maximum will be equals to maxi. Maxi now will become nums of I. Minimum, that is mini, will become nums of I, right? And we will update the set bits to underscore underscore built-in pop count, and in this we will give nums of I, right? Now after this loop finishes, you can check again that if mini is less than previous max, then return false, otherwise you return true, right? So let's run this now. So our test cases are accepted. Now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.